Now, so long as we're talking about misconceptions about gravity and physics, let's talk about my favorite one. This is my absolute favorite conversation to have in this entire class. And for some of you, I've already had this conversation. This is the one thing that if you go and tell anybody else about one part of this class, this is the funnest thing to talk about. This is one of the most common misconceptions people have. And it's really fun to think through this one. So you see these astronauts here on the screen. I think you've all seen footage like this of astronauts. This is on the International Space Station, which is orbiting the planet. These astronauts are in space. And the question is, why are they floating? Why do they seem to be floating? We often use the word weightless. Why are they weightless? Sometimes we use the word zero gravity because the common answer is, you guessed it, there's no gravity in space. Go ask anybody you want on the street, and this is what most people will tell you. Well, they're floating because there's no gravity in space. You've probably been told this by some very well-meaning elementary or middle school science teachers who just didn't know any better. Maybe they were taught this as well. Now you're going to learn the truth. So there's no gravity on the International Space Station, right? Well, I have a few more questions for you. What is the International Space Station doing? Well, we just said it's orbiting the Earth. Okay, cool. Because of what? Because of gravity. And now is when people go like, well, wait a second. What do you mean? Because in case you didn't notice, you just gave me two answers that are contradictory. In one, almost everybody that I have this conversation with says there's no gravity on the International Space Station, but they can also tell me that the International Space Station is orbiting because of gravity. Only one of them can be true. There either is gravity or there isn't. So let's think about this. Here's the Earth and the Moon right here. The first thing you need to know is this is not at all to scale. We would need to do this. That's better. Can't see. Let's turn the lights out. That's better. So this is the Earth and the Moon. This is approximately to scale in terms of their size and how far away they are from each other. They might even be a little bit smaller than this. So if we look at the International Space Station, the question is, where is the International Space Station? Is it here, somewhere in the middle, out here, about a quarter of the way? Where do you think the International Space Station would be? Here's our space station. Oh, we need to make that guy smaller too. Shrink him down. Should even be way smaller than that, but we still need to see it. So where is it? Where does the International Space Station go? Take your pick. Make a guess. Because the truth is, it goes right there. Maybe even closer. International Space Station really just needs to get outside the atmosphere. All the satellites that are orbiting our planet are just outside the atmosphere for the purpose of getting away from air resistance due to friction. So that's where that guy is orbiting. That's where the International Space Station is orbiting because of gravity. It's useful in this situation to think about the moon because same question, what's the moon doing? Well, the moon is also orbiting. Why is the moon orbiting? Because of gravity. So if there's gravity out here, if there's enough gravity out here, because this is the other thing some people will say, oh, well, there must just be less gravity. Well, there's less gravity on the moon itself, and you've seen footage of astronauts jump up and they come back down. That doesn't happen to the astronauts on the International Space Station. Regardless, even if the case is that there's less gravity, if there's enough gravity out here for the moon to orbit, there's got to be enough gravity right here next to the Earth. So let's just settle this and put it to rest right now. There's no gravity in space, huh? False. You have to know that this is false. Gravity is all over space. We can't get away from gravity, certainly within our solar system, within our Milky Way. The force of gravity is always in existence here. So it's not true that there's no gravity in space. But still the question remains, why are these guys floating? Are you ready for this? Here's the answer. They're not. And now you're like, huh? What are you talking about? What do you mean they're falling? They're falling? Yeah, they're falling. Check it out. Let's think about this. So let's imagine that we shoot an arrow. We shoot an arrow from a bow. What happens? Well, what happens is it hits the ground. It hits the ground because of the force of gravity, that it's traveling horizontally, but gravity is pulling it down at the same time. So it's got horizontal speed and it's falling at the same time, and it takes a path that looks like this. Okay? Easy enough. Next scenario, let's say we shoot the same arrow from the top of a not that tower. That's better. Let's say we shoot the same arrow from the top of a tower. What happens now? Shoot it. Same thing, except now instead of landing here, we shot it higher, so it's got more time to, before it hits the ground, more time to fall, therefore more time to move horizontally. So it hits the ground a little bit farther away. Okay, that was the second scenario. Third scenario. Let's say we take this tower and we can make it super duper tall all the way up above the atmosphere. We're going to build this tower so that we can now shoot the arrow outside the atmosphere. What happens now? Well, many people guess, oh, the arrow is going to go in orbit, right? Not yet. Arrow's still going to fall. It's going to go farther because it's shot from a much greater height, but gravity, as I said, is everywhere. It's still going to act on the arrow. It's still going to make the arrow fall. The arrow will go farther, but it's going to fall. The reason why the arrow doesn't go into orbit is this right here. The speed of this arrow at most is 200 miles an hour. Let's consider another scenario. Same tower, but now let's shoot that arrow at 17,500 miles an hour, right? Whoa. Oh, you got to zoom out. Now, ladies and gentlemen, we have orbit. So this arrow is now orbiting because we shot it at 17,500 miles an hour. This is orbit speed. This is the speed that rockets have to achieve in order to go into orbit. Here's the deal. Orbit is just perpetual free fall. This arrow is falling just like all of the other arrows were falling. The astronauts on the International Space Station are falling just like the arrows are. The thing is, they're falling and the whole space station is falling along with them. In other words, they're all doing the same thing. So it just looks like they're floating. Here's the deal. A lot of people go, well, if it's falling, why doesn't it hit the ground? While it's falling, it's also moving so fast horizontally so that the curvature of the Earth, the surface of the Earth itself, curves away from it. Because after all, you may not have ever thought about this, you only hit the ground because there is a ground. Well, what if you're going so fast that the ground is curving away from you? Well, the answer is then you enter into orbit. If that doesn't make sense to you, watch this next video.
You reckon there'd be no gravity there?
There's not much. They float. We've seen them.
Well, clearly there's not. They're floating around.
I know they float. And the question is why?
No idea. I'm really confused.
Well, in truth, the force on the astronauts is almost as much as the force on you. So then, why are they floating while you're stuck here? The answer is the astronauts aren't floating, they're falling. Ah! And not only that, but the space station they're in is falling as well. Ah! So why doesn't the space station come crashing into the Earth? Well, the reason is the space station and astronauts inside have this huge sideways velocity of about 28,000 kilometers per hour. So even though they're falling towards the Earth, they're going so fast that as they fall towards the Earth's surface, it curves away from them. If the Earth didn't put a gravitational force on them, they would fly out into space.
Sure, yeah.
Right? So it's due to that gravitational pull that they can actually keep orbiting the Earth.
So the ultimate takeaway here is that to us, the astronauts will seem like they're floating, but it's just an optical illusion. They're just falling, and they're falling along with everything else behind them. See, what happens is our minds use context clues to draw conclusions about motion. Let me show you what I mean. Consider this video that we've watched before about the bowling ball and the feather falling. If you watch this and think about it, I'm going to ask you the question, even though it's in slow motion, you know these things are falling, but why? How do you know that the bowling ball and the feather are falling? What if I stop this right here, and what if I do this? What if I zoom in on it and remove the background? And I replace the background with the International Space Station. And now I hit play again. Now it looks like the bowling ball and the feathers are floating. But they're doing exactly the same thing they did in the other video. See, your mind uses the external cues around you to judge motion. When you're in a car, one of the things that lets you know you're moving is the things beside you are passing you. In an airplane, it's hard to tell you're moving sometimes because when you look out the window, you don't see anything passing by. So the fact that all of the objects in the space station are doing exactly the same thing and they're not moving relative to each other, our minds tell us that they're not falling because on this planet, every time you fall, things pass your field of vision. Your mind tells you you're in motion. See, just like when people do green screens, there's a fake background here that's going on. Because these cars are really not moving, but all I have to do is put a moving background on there and my mind tells me that they are moving. So again, it's the context clues that give us the idea that an object is moving. In the case of an astronaut on the space station, those context clues are absent. And so most of us seem to think those astronauts are floating when they're actually just falling, along with everything else in the space station.